Hello and welcome to the Homework Helper First 9.6. I realized I didn't get this up last night. We had a bit of a long meeting after school yesterday. I didn't have a chance to get this going. But let's go ahead and get this thing started. What I want to start with actually is when we look at this number line, the finding distance and averages, it's mismarked. This 15 should actually be here. It's not that big of a deal, but because the distances that we're looking for are going to be the same, but it is kind of a terrible typo to have. So this is actually supposed to be 15. So it says find the distances between point A and each of the following on the number line. So we look for A to F. So A to F is 1, 2, 3, 4, 5, 6, 7. So it's a distance of 7. A to C, 1, 2, 3, 4. A to G, 2. A to B, 1. A to D, 1, 2, 3, 4. And then A to E is 6. And so then what we're going to do is we're going to look at the distances from point A. And we're going to tally them all up. So 7 plus 4 is 11, plus 2 is 13, plus 1 is 14, plus 4 is 18, plus 6 is 24. And so now let's find the average. So we'll do 24 divided by the number of points that we did, which is 1, 2, 3, 4, 5, 6. We'll divide this by 6, which comes up to, what does that come up to? 6, 4, 5. Is that right? That's not right. That's not right. It's 4. Okay, so we know that the average distance is 4. Which point or points on the number line are located at the average distance? So if we go 1, 2, 3, 4, we see that D. If we go backwards 1, 2, 3, 4, we see that C is 4 away. Okay. And so just kind of follow this section step by step as we begin to look at the different ways these averages matter. Okay, let's go ahead and turn the page. Create a scatter plot. So again, when we're looking at this, when I'm looking at what my English scores are, I see that I have a low of 44 and a high of 70. So when I'm making my scatter plot, maybe I have this be, 44, and then if I go all the way to 70, can I go by 2s? 46, 8, 50. Yeah, I can totally do that. So this is 44, 48, 46. I'll call this 50, 2, 4, 6, 8, 60, 2, 4, 6, 8, 70, and that's as far as I need to go. So these are my English scores, and then these are my history scores. I have a low of 57, so I'll call this 56 just to keep the numbers even. I need to get all the way up to 67, so 8, this would be 60, 2, 4, 6, 8, 70, 2, 4, 6, 8, 80. Okay, that's plenty. Okay, now I can plot these. So I have 60, 65. So here's 60, 62, 64, 65. I have 53. So 52, 53 is in the middle. 59 should be right here. 44, 57, so 44, 57. 61, 61, so 61, 61. And then 70, 67, 70. This would be 66, 67. So there we go. Those are our points. Do they seem to have a positive or negative correlation? Well, it seems as one goes up, the other goes up. So I would say it is a positive correlation. Is it strong or weak? It's kind of linear, so I would call this stronger than it is weak for sure. All right, and which graph below models the data? Oh, this is a different question. Which graph below shows the best model for the data? So look at this line. You see how this one we have all of these clustered underneath, these clustered over in the middle. It doesn't really feel balanced, right? It's kind of more of these are on this side than that side. This is the same way where like all of them except one are on top, which also doesn't feel balanced. Well, this one feels just right because we kind of toggle between above and below, above and below. It feels like it's really shooting through the data, weaving in and out. So I would say C would be the best fit. Okay. Finally, let's go to given the following data, let's create an explicit rule for each function. So f of 2 is 7 and the common difference is 3. So we're going to, so it's common difference, so we know that this is arithmetic. And so just like a little refresher on our arithmetic and geometric sequences, because it has been a while, our arithmetic sequence is we're going to have f of x equals our n sub 0 plus our common difference times our x, which is really the same thing as y equals mx plus b. M and common difference are the same thing, n sub 0 and b are the same thing. Whereas when we're talking about geometric, we're going to have, so this is arithmetic. When we're talking about geometric, our f of x is going to equal our n sub 0 times our common ratio to the x power. Okay. So when we're looking at this, I see that this is common difference. And what we aren't given is we're not given what our starting value is, but we are given what our second value is. All right? We're given that our second value is 7. And so if our common difference was 3, we would know that our first value was 4 because it's 3 less, and we know that our 0 value was 1 because that's 3 less. So I just know from using this equation that f of x is going to equal our n sub 0, which is 1, plus our common difference, which is 3, times x. We have it just like that. And we can do this for all of them, like I'll do number 19. So we have h of 6 is 3. We know our common ratio is -3. Okay. So this is going to be a bigger t-chart. So boop, boop, boop. So I know 6 is 3, okay? So if I'm going to work backwards, 5, 4, 3, 2, 1, 0, I'm going to have to divide by -3 each step. So 3 divided by -3 would be a -1. Divided by -3 would be a positive 1/3. Divided by -3 would be a -1/9. Divided by -3 would be a positive 1/27. And then divided by -3 would be a -1. Ooh, what's 27 times 3? I don't know that off the top of my head. Wait, yes I do. 81? I think it's 81. Hold on. 27 times 3. 81? All right, I'm so smart. Okay. So -181. So I now know what my n sub 0 is. So I know that my equation here is f of x is, here's that part, right? My n sub 0, which is a -1/81 times my common ratio to the x power. So it's all about just working backwards, plugging and chugging, and figuring all that out. Okay. So that's 9.6. One of the things that I didn't have time to do was 9.7, so we'll go ahead and do 9.7 as well in one video, just to keep it easy. So here's the homework helper for section 9.7. So we have the line y equals x, and then we're going to use the graph to answer each question. The vertical distance between points n and on the line y equals x on the graph is 3. So here's n, here's the vertical distance, this is 3. Okay. Find all the vertical distances between it. So, okay, B is also 3. D is 0, it's on the line. E is also 3. G is on the line, so 0. I is 1. L is 1. N is 3, we already knew that. And X is 2. Okay, I found all the vertical distances. So now it wants us to sum all of the distances that we found. So let's add them up. 3, 3, 6, 6, 7, 8, 11, 13. Okay. So what is the average distance? So now I take 13 and divide it by the number of points that I have. How many points did I have? 1, 2, 3, 4, 5, 6, 7, 8. So I did take this divided by 8. So 13 divided by 8. Divided by 8 is 1.625. Easy enough. And then, is the line shown on the graph the line of best fit? Explain why or why not. If it's not, draw the line of best fit. I do not believe this is the line of best fit because we have 2 points above and then we have all of these points that are on or below. I believe that the line of best fit, let's get rid of this calculator. I believe that the line of best fit would be a little bit closer to something, I'll deal with a different color, probably something a little bit closer like this, right? 1, 2, 3, 4. Yeah, I got like 4, maybe I would have wanted to scoot that a little bit higher, but here I have 3 below, 4 above, and 1 on. It seems a little bit better. Seems a little bit closer to what we're trying to do for a line of best fit. Okay. All right, let's go ahead and go to the next section. There's a few more questions there, but you can handle those. Okay, we're going to determine whether a linear or exponential model would best describe the given scatter plot. So when I look at this, I'm wondering, is a linear or exponential model the best? And I can kind of see, you know, when we're talking about exponentials, we remember that they go like this. They have that sharp curve. Whoops. And when we're talking about lines, they go up and, you know, it's a pretty straight line. So when I look at this, it kind of looks like it curves up, right? So I would say this would be an exponential model, whereas this would be pretty clearly linear. A linear model would work best. Awesome. And then we're going to make a scatter plot. At this point, we should be pretty good at making these scatter plots. All right, and finally, let's actually skip the first couple questions and go to this, because this is the hard part. It's about whether or not it's a function. And remember, when we were talking about functions, we're talking about the vertical line test. You know, when we look at this, when we look at 1, we have all of these are going to 12. So what would that mean? That would mean if this was 12, it'd be like boop, 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 boop. That would absolutely pass the vertical line test. Each x goes to a y, that's fine. But when we look at number 12 here, look at what happens. We have 2 that goes to both 30 and 20. So if I were to graph that, here's 2, and here's 20, here's 30, it would be right on top of each other. So that would fail the vertical line test. So that would not be it. Okay, so if it fails that vertical line test, it's not a function. So if an x goes to 2 different y's, it's not a function. Okay? And so that's what you're going to be looking at. You're going to be looking to see if we have an x going to 2 different y's. And if we do, we're going to end up with something that's not a function. All right. That's it. That's the homework packet. How cool is that? Study hard. We'll have our quiz on Friday. And good luck with Chucks.